Hello students, welcome back. In the previous video, we established the Cartesian coordinate system, and let's do some work on it. Here's a motivating example. We have rather complicated equation of two variables, x and y. And don't be intimidated. I'm not asking you to do anything algebraically with this. It's complicated, it's going to be impossible. And geometrically, on the other hand, we can use technology to represent this in terms of a curve in two-dimensional space, or as a matter of fact, as you can see, two pieces of curves. The equation itself was complicated, not coincidentally. The graphical representation, the curves, were also very complicated. Here are some questions that you have to answer. Is the point -1, 1 on the curve? What do you mean by -1, 1? Well, in Cartesian coordinate system, every point is represented as x, y, a pair of real numbers, right? And x, the first one is horizontal to the right, and y, the second one is vertical upward. So basically -1, 1 is -1 step to the right, or 1 step to the left, and 1 step up. Let's see, 1 step to the left, 1 step up. Looks like we have this point over there, and that point looks like it's right on the curve. So looks like this curve is right on the curve. How about the other point? So x, y is 1, -1. Let's use different color to differentiate these. Okay, 1, -1, where is it? Let's look at the curve. 1, so to the right, 1, and -1, we have to go down -1, around here where my mouse is. I don't see any curve going through here, so it looks like this point is not on the curve. Those are my educated guesses just by eyeballing those pictures. Well, did I do this right? Let me justify those, and justification is rather simple as a matter of fact. All I have to do is to go back to this algebraic expression and check -1, 1. X is -1 and y is 1. Plug those in as you did over here. See, from here, plug in x equals to -1, so -1 to the 4th power, -1 to the 5th power, and so on and so forth. And see if this identity is correct. Yes, we ended up with 4 equals to 4, and that's something you can easily check with calculator. I'm not asking you to do this with mental math. It can cause a bit confusion and possible stupid mistake. Use calculator. Now what if you plug in x equals 1 and y equals to -1? Well, we have this kind of algebra here, and then run your calculator, you're going to get 4 equals to -2, which is clearly false. So no, this red point is not on the curve. Here's a graphical justification for that. -1, 1, yes. 1, -1, no. So how do we check a given point is on a curve or not? Well, eyeballing is going to give you some good idea, but it will not give you precise idea. Plug it in and simplify with help of some technology. That's going to be the precise argument. Okay, we went through an example, a motivating example, and some pretty picture, and also some example of checking a point on a curve. Let's go to the next topic, intercepts. What do you mean by intercepts? We're looking for particular points that are cut by x-axis and y-axis. Here's a picture. Oops, excuse me, and this is not the picture I want. Sorry about that, let me correct it. Okay, I updated my module as a matter of fact. So, okay, that's the picture I used in previous problem. Okay, alright. And then let's look for x-intercepts and y-intercepts. Horizontal is the x-axis, So the x-axis looks like it's cutting this curve twice, one here and another over there. And I'm looking for these x-coordinates. This x-coordinate looks like about x equals to 1. And these are my guesses. Around here, -1. Here, -2. There, 2. So around here, in the middle. These are my guesses. By the way, I'm guessing here, so I have to use proper notation for guesswork. So instead of equality, let me use regular equal, which means approximately equal, or just a guesswork. Okay, alright. Even further, I'm putting question mark there to represent this is just a guesswork at this moment. Now let's make this guesswork a precise computation. Oh, excuse me, before that, another guesswork first, y-intercepts. So this y-coordinate and that y-coordinate. 2 points cut by the y-axis. This one looks like y equals to 1. That looks easy. Not equal, approximately equal to 1. Now how about the next one here? -1 is around here. -1/2 is there, even closer. So my guess is -0.4 approximately. Well, at this moment, it's just an eyeballing. They're just guesses, so this is as good as any. Let's find out precise answers. For precise answers, these pictures are no longer necessary. So let's go back to this. And let's find out. Oh, excuse me. I was a bit premature killing this picture. I'm looking for x-intercepts, right? So these 2 points cut by the x-axis. Okay, let's look at this. I'm looking for x-coordinate, but what's the y-coordinate? Y-coordinate is 0. Do you see it? Y-coordinate is vertical distance from the x-axis. And I didn't move away. I'm right at the x-axis. So vertically, I moved 0. Same goes over here. So y-coordinate is 0. That is the key. In other words, if you're looking for the x-intercept, you should do this. From the algebraic equation of this original curve, you're going to plug in y equals to 0. So, okay. Y equal to 0 to the given equation. Put y equal to 0 and find out the x value. So I'm going to plug in y equal to 0 here. Okay, copy and paste it. So, okay, let me plug in y equal to 0. And then this will be 0 squared, so that's 0. And then this will be 0, right? But then again, anything times 0 is 0, so I didn't really have to do it this way. This entire thing drops out. 0 squared times 5, that drops out. 3 times 0, that drops out. So what do you get? We get x to the 4th power is equal to -x squared plus 2. That's what I'm getting. Can we solve this equation? If it is quadratic, I can do it, but looks like it's 4th order. How do I do that? Do I have to give it up here? No, actually, we learned how to do this. Even though this is 4th order, it's trinomial equation. So move everything to the left. Oops. -2 is equal to 0, all right? And let's go from here. If this had been x squared plus x minus 2, I could have factored. We have x squared squared and x squared, so it's going to be a bit of a variation. So it will be x plus 1 plus 2, x minus 1, if it had been x squared plus x minus 2. But these are different. We need this adjustment. See? Fourth power is square square. So if I start from x squared, we have the factorization. Now, setting first factor equal to 0, x squared equal to negative 2. That's complex number. I don't get anything. X squared is equal to 1. Okay, I'm going to get something there. That's one way to handle it, but I prefer to do it this way. X squared plus a positive number, that's irreducible. I can't do anything. But x squared minus something, I can certainly do it this way. What did I just use? Oops. I just factors x squared minus 1 squared a bit further. So x plus 1, x minus 1. I just got that. And then from the first factor, I get nothing. From the second factor, I get x equals to negative 1. And finally, from the third factor, I get x equals to 1. This one is x squared plus 2 is equal to 0. That doesn't give me anything. X plus 1 is equal to 0. That gives me x equal to negative 1. And x minus 1 equal to 0. That gives me x equals to 1. Now compare those with my initial guesses. Perfect guess. We have the answers all confirmed. I don't need any of these because I already have all these in my answer key. Plug in y equals to 0, solve for x from there, and then we get the same process and x equals to 1 or negative 1. And here is graphical justification, or verification if you prefer that word. Okay, let's hurry back to the second problem here, and let's try to complete everything in a single video. Okay, let's do the same thing here. This time, I'm looking for these 2 points, so x coordinate is 0. Horizontally, I didn't move anywhere, so we are doing this. And plug in y equals to 0, so that's 0. Y equals to 0, that 2 is 0. And that's 0. So what do you get? We get x to the... Oh, excuse me. I'm looking for y-intercept, so x is 0 this time. So plug in x equals to 0, so that's 0. Plug in x equals to 0, so that's 0. And plug in x equals to 0, so that's 0. I'm looking for y coordinate. 5y squared equal to 3y plus 2. And this is nothing more than just a quadratic equation. How do you factor this? I usually use tic-tac-toe method. You may use some other method, but whatever you use, my expectation is everybody should be able to do this. Here we go. 5y plus 2y minus 1 equal to 0 should be the solution, and you can easily check that. Multiply 2 times negative 1, negative 2, that's a constant, okay. 5 times negative 1, negative 5, 2 times y, negative 5 plus 2, that'll give me negative 3. Yes, this is correct substitute. This is correct. And then from the first factor, we get y equals to negative 2/5 by setting it equal to 0. And from the second factor, you're going to get y equals to 1. And what a guess! Negative 0.4 was perfect guess. We have the solution here. Plugging in x equal to 0. And then solve for y. That'll be this quadratic equation. And after factorization, we get negative 2/5 and 1. And finally, we have graphical verification.